In this lecture, we will be learning about the Loft command found here on the Command Manager. The Loft command allows a series of 2D profiles that exist on separate planes in 3D space to be blended together into a single 3D form. To demonstrate, I'll select the Loft command. The first box here we have is Profiles. Each of these sketches is a 2D profile that I'll select in sequence. And we see what is happening is the solid shape is slowly evolving as I click on each profile in turn, and it's blending the shape of the solid from one profile to the next. The final result is a smooth solid that has compound curved sides that cannot possibly be made with extruded solids or extruded cuts. This is the type of command we will use to make something like the fuselage of an airplane, the body of a car, or the hull of a ship. The example I just showed used profiles that were relatively similar to each other, just circles and ovals, but I can also blend together completely disparate shapes. This doesn't make what I would call a very pleasing form, but you can see that Solidworks is able to successfully blend them all together. Now let's look at something that's a little bit more reasonable and practical. And here we see one half of what is going to become the hull of a wooden ship. This line represents the keel. This is the center of the deck, and this is the outer ridge of the deck, often known as the gunnel. Here we have profiles that represent the ribs that hold the shape of the hull. On a real ship, we would add planking to the ribs that spans the length of the ship and bridges from one rib to the next, and also the planking goes downward toward the keel in order to create one smooth form going in this direction and in this direction as well. This concept of the wooden planking blending from one set of ribs to the next is pretty much the exact same concept that's used when SolidWorks creates a loft. So let's see how this is going to look. I'm going to select the rib profiles each in turn. We see that the shape of the hull is slowly building up. If we look at the finished result, we see that it doesn't really quite match the shape of the keel or the outer ridge of the deck. We can modify this by activating the guide curves and adding our keel, the center of our deck, and the outer ridge to this loft creation. So I'll go ahead and do that. Keel. And we see right away as I add that guide curve, it starts pulling this loft into shape. Center deck, outer ridge, we have the completed form. What the guide curves do is help manage that transition from one profile to the next. We saw that without the guide curves we were quite off the shape of the keel, and the only other solution would have been to have added additional profiles in between this set of ribs and the bow of the ship. But that still probably wouldn't have gotten us a very accurate result, and the only other way would be to continually add more and more profile curves in an attempt to try to get this shape to conform to what we want. That's not a very efficient way to build this, so it's much better to have a combination of guide curves that control the overall outer shape and then an economy of profiles that are just enough to manage the three-dimensional shape that's blended together. I can go ahead and finish the shape of this simply by mirroring it. And I have my completed ship hull. Now, as you saw in the very first example with the circles and ovals, it's not necessary to have guide curves to control your loft. However, guide curves are the very best way to control the shape of your loft to get something predictable, and I would estimate I use them about 95% of the time. When making your guide curves and profiles, it is best to make the guide curves first and the profiles second, forcing the profiles to conform to the shape of the guides. This is opposed to doing it the other way around, where we draw a series of profiles on separate planes first and then try to draw guide curves that connect these profiles together. If you try to draw the guide curves to conform to the profiles, you're probably going to have the same kind of problem you have if you make a spline with too many points. The chances are that you're going to get a little wave or lump in your guide curves, which is undesirable. Also, the guide curves should be doing exactly what their name suggests. They should be guiding the overall shape of the object you are trying to create. In order for a guide curve to be valid in the construction of a loft, it has to span all the way from the first profile plane to the last. We cannot have a guide curve that starts somewhere in the middle and ends somewhere in the middle. Also, it's generally not a good idea to have a guide curve go beyond the last profile or beyond the first profile plane. Also, every single profile that is included in the loft must touch every guide curve that is going to be used in the loft. So here we see this profile touches at these three corners this curve, and this curve. Every guide curve or every profile must do that. So let's just roll this back and look at the process of making one of the profile sketches. Here we see just our three guide curves, the center of the deck, the outer ridge, and the keel. And I'll mention that this is actually a three-dimensional curve. The other two sit on the front plane. In another video we'll show the method for constructing this type of a curve. Already constructed are a series of planes. I'll just go ahead and show these for a moment. It will be used for drawing each of the profiles. I'm hiding the planes again, and I'm just going to select one in the middle of the hull here to demonstrate the process of drawing a profile. So selecting that plane and going to Sketch. What we want to do is create a horizontal line. It's going to span from this guide curve to this guide curve. That'll form the upper deck. A vertical line that spans from this guide curve down to the keel. That'll form the flat face that will be on our front plane. And then we want to draw a curvy line, a spline, that will span from this outer ridge guide curve down to the keel here. You'll recall that was one that had a sort of a curve like this. And that's what created the outer shape of the hull. We have to make sure that the three corners of this sketch are going to intersect or be coincident with these three guide curves, and they have to be coincident with the guide curves where the guide curves pass through our sketch plane. This requires a new type of relation, which is sort of like a super coincident relation known as Pierce. Pierce allows us to make coincident relations to lines and curves that actually pierce through our sketch plane. And there's an excellent video I found on YouTube that further explains how this works in case you're having trouble understanding it in this video, and I'm placing the link for that in the description to this video. So I'm going to draw the first two lines from my sketch, horizontal line and my vertical line, and these are just out here in space somewhere. What I want to do is make sure that this point is coincident with this line, this point with this line, and this point with this line. And I'm going to use the aforementioned Pierce relation. I'll hold down my control key and this line. One of the choices I get is a new one called Pierce. What that does is it drops this point onto this line. I'll do the same with these points here. We see we have a new symbol for that relation, and this is one relation which is actually shown in color. So why is this called Pierce? Now imagine that our sketch plane is like a piece of paper, and our guide curve is like a very thin wire that is punching or piercing through that piece of paper. Where it forms a hole in that piece of paper, that is where we are making our actual coincident relation. So the coincident relation would be to this curve, but not just anywhere along the curve. It's the point where the curve passes through the sketch plane. Using a regular coincident relation will not work in this case. It must be a Pierce relation. Let me go ahead and finish this sketch. I'll just do a 2-point spline here. And I'll just drag out the handles to get the shape of the profile in this location. If any of these corners did not touch their appropriate guide curves, such as I'll remove this pierce relation here, and I had a situation like this, it's most likely that the loft will fail because there's a contradiction. Solidworks is going to try to satisfy the needs of this guide curve and try to satisfy the needs of the profile at the same time, but there'll be this contradiction here where it can't possibly do both at the same time. This is why guide curves and profiles must touch each other. Now here we are back to our series of profiles and guide curves. I want to stress that profiles always have to be an enclosed two-dimensional shape. There is one exception to this, and this is going to be on the bow of the ship. I'll take a look at this profile, rib 0. And this is the one allowed exception where you can have just a single point being your profile. This point, as we see, is actually meeting at 3 separate guide curves, but we only have one pierce relation. We can actually choose any of the 3, and since they all meet at the same point, it doesn't really matter which one we choose, but I would recommend choosing either this one or this one because they lie in a flat plane. So there's maybe slightly less chance that an error would occur when trying to make the loft. Now that we have all the elements that we need, let's talk about the best way to select them when creating the loft. Profiles and guide curves can be selected from either the feature tree or from the graphics window. However, there's one case where it's going to be difficult to select from the graphics window, and that's going to be this first profile, which is a point, because it also meets where the other 3 guide curves come together. So you might try to select this point and instead end up selecting the guide curves. So this first profile is almost easiest to select from the feature tree, as I'll show right now. Going into Loft, of course we start with profiles first and then guide curves second. When the Properties Manager is open, the feature tree gets shifted into our graphics window so we can open it up by clicking on the plus sign. The first profile is rib 0, so I'm going to purposely select it from the feature tree. The others I can select from the graphics window if I like. And you see what happens is sometimes you'll get an inadvertent twist. Let's delete some of these. In the loft if you don't pick the profiles properly. Obviously, as each profile is blended together, we want common corners to link together. So these corners should all link together, and these corners should all link together, and so on. What we don't want is for this corner to try to link up with this corner, and this corner to link up with this corner. That introduces the twist you just saw. So let's go back to making the loft. What we want to do to help avoid this is try to pick each profile near the same corner consistently. So I'll pick this profile near this corner, this profile near the same analogous corner, and moving along to eliminate that twist. Now sometimes you'll still get a twist whether you like it or not. Sometimes that'll occur if you select completely from the feature tree, or sometimes it's hard to get it to select the same analogous corners all the way down the length. You don't have to panic here, you can always fix that. So we'll start here, move to this profile, and I'll purposely pick this one at this corner just to demonstrate the twist. So it's trying to connect this dot to this dot. The way we fix this is we can just use our left mouse button and drag the dot to any of the 3 corners of the profile. So you see I drag the dot back to this corner, which is analogous to this one in this profile, which lines everything back up. Now I can just continue moving along. And even if I accidentally botch it, which causes the entire loft to fail now, we see we've lost the preview, I can still go and grab this dot, move this to its appropriate location, and the entire loft comes back. Sometimes we can accidentally forget to pick a profile in the proper sequence. So if I start here, move on to this one, and maybe I accidentally skip this one here, come along here, then I realize after the fact that I need to add this one back in. If I go and click on this profile, again I get a failure because it's trying to link them together by looping back to this last one that was selected. Again, I don't have to panic. We see here rib 2 at the bottom of the sequence. I can highlight that and move it up to the appropriate location in the sequence, and once it gets back to its proper location, once again the loft comes back. Occasionally we can finish the loft and not realize that we've left a profile out altogether. So I'll just delete this one profile. I'll go ahead and put my guide curves in first. Usually there's no problem just selecting the guide curves directly from the feature tree. So I've completed my loft, and I suddenly realize here that rib number 2 was not included in the loft because we see that it's not absorbed into the loft feature. I don't have to delete the loft and remake it. All I have to do is edit the loft, right click, edit feature, make sure that the profiles box is highlighted, and go ahead and select the missing profile. Again, it's going to fail because it's going to try to put it at the end of the sequence. And once again, I'll just use the arrows and move the profile to the proper location. One of the things that we see here on the completed loft, if we click on the plus sign, is all the separate pieces that went into making it become absorbed into the loft features. So even though these had to be created ahead of time, they now look like they're actually occurring later in time than the actual loft creation. This is one slightly confusing thing about Solidworks, is that things that came earlier, once they get absorbed into a feature, look like they're coming later. But these, of course, in order to be absorbed into the loft, had to be created before the loft could be created. So let's talk about some common problems that can occur when trying to make a loft. As I mentioned before, every profile has to touch every single guide curve. Here's an example where this profile is not touching this outer guide curve at this corner. We'll go ahead and try to make a loft from that. It has no problem making the loft just now because I haven't yet added any guide curves, but as soon as I try to add my guide curves, right away we see that the loft disappears. And if I try to finish the loft, I right away get a rebuild error that says guide curve number 1, that's this one here, is invalid. It does not intersect with section number 3, so that's this section here. So I would have to repair this by editing this profile and moving this corner on to the guide curve using a Pierce relation. Another problem is having a guide curve that does not span the full length of the loft from the first profile plane to the last, as we see here on this top guide. So again, trying to make the loft. There's no problem when I first just select the profiles. The problem occurs when I try to select the guide curves. So we'll just select this top one. Once again, the loft disappears in the preview, and if I try to finish the loft, again it says guide curve number 1 is invalid. It does not intersect with section number 6. This is section number 6, and we see the guide curve does not make it all the way to that section. Another problem that can occur is when we have guide curves that are supposed to meet that do not meet. Here we have 3 guide curves that properly span the full length of the loft from the first profile plane to the last, but we know that the end of this keel is supposed to meet at the top of the deck. They have to meet because this is supposed to be a sharp point, and there's only a point in this particular profile. So let's look at what happens when we try to make the loft. Again, there's no failure when just selecting the profiles. But now we'll go to the guide curves, select each in turn. What's interesting here is that the loft is not failing, but we can see that the bottom ridge of the keel is not following the guide curve that was selected. It's actually allowed me to make the loft in this case, surprisingly, but technically I would call this an error because we have not gotten the shape that we actually were desiring based on the shape of this bottom guide curve. This last issue is technically not an error, but it does have to do with making nice looking lofts. So here again we see the hull of the ship, and we have this sort of an unsightly bulge in the side here. What I'm going to do is show the profiles. We see the bulge is occurring right about in this area, and we can see that the shape of this profile is a little bit different from the others. A trick here, when you have an unsightly transition, is to sight down the length of your loft. I'm going to delete the loft here for a moment just to make it a little easier to see what's going on. And here we see that these profiles sort of nicely follow each other and sort of nest within each other. But we see this one particular profile, which is almost the same size as this one, is bulging way out and actually crossing over this profile here and crossing back over it again here before finally coming down to the keel. If I want to fix that, I want to drag these handles and get this profile to look like it's more nesting in with the other profiles and following this general trend. And now we see that it's not crossing over this profile like it was before. Now if we go ahead and make our loft, we should get a smooth result. And there's the completed result. That's the end of this lecture. To further appreciate how to make good lofts, you'll probably want to learn a little bit more about the Pierce relation and how to also make projected sketches, which will be shown in other videos.